Okay, today I'm going to be shining the world's brightest flashlight on the world's blackest black. So we're going to be seeing if we can get any light to reflect off of it at all, and we're going to be testing how hot it heats up due to the absorption of the visible light. So for example, here's a ping pong ball that I painted with black 2.0. So it looks almost like a black hole. You can't see any of the curvature of the ball at all. It looks like it's a flat circle. You can even paint very shiny things with it, and it becomes like a black hole in it. So it's really fun paint to play with. You can make things like this, make yourself a black hole if you want. So Vantablack can absorb 99.965% of visible light. And Black 2.0 is similar to Vantablack, but I couldn't get any real value for how much light it absorbs. So my experiment today is seeing if we can get a reflection using the brightest light shined against the blackest black. Will the dark side or the light side win? Let's see. So this is touted as the brightest flashlight on the market. It can put out a whopping 32,000 lumens. It's amazing. So to give you an idea of how bright 32,000 lumens is, the sun puts out around 10,000 lumens per square foot. So that means that when you shine this flashlight on the ground, it's 3 times stronger than the sunlight on the ground next to it. So for example, let me show you the settings on here. So this is a normal flashlight range, 120 lumen. The next setting up on it, 500 lumen. You can see it getting a little brighter in here. Next step up, 1500 lumen. Next step up, 5,000 lumen. The next one up from there, 13,000 lumen. And then the next step up from there, okay, here's 120 lumen. Let's jump up to 32,000 lumen. 3, 2, 1. Holy cow, it's amazing. This is a flashlight. It's like a spotlight. So crazy. So lighting is hard with the camera because the camera auto-corrects for the lighting, and so it's hard to tell when something gets brighter. It's literally like I'm holding a spotlight in my hand. I'm predicting that the 32,000 lumens are just going to totally overpower the Black 2.0, and you'll get a strong reflection on it because this is really bright. And I want to test how hot the Black 2.0 heats up when I shine this light on it. Because when I just put my hand in front of the light when it's shining 32,000 lumens, it heats my hand up to almost burning. So look, you can totally see the flashlight on there. If this Black 2.0 were really absorbing all of the light, you wouldn't be able to see a shadow on there at all. But you can totally see my hand shadow on it. So this means the 32,000 lumen flashlight overpowers the Black 2.0. So now let's check how much the Black 2.0 is heating up due to the flashlight on it. Okay, so before I shine the flashlight, it's about 20.1 degrees C, 20 degrees Celsius. So now we'll shine the flashlight on it and see what it jumps up to. Whoa, 24, 30, 33, 40, whoa, that's heating up fast. Look, you can just see the glowing red circle on there. So know that this flashlight is an LED flashlight and not an incandescent bulb. So it's putting out mostly just visible light, and the heat is coming from the black absorbing the visible light and turning it into infrared or heat. So it looks like it gets to around, it's going to about 55 degrees Celsius. Now let's compare that to what I do if I shine it on the white wall. So a white wall gets to around 30 degrees Celsius, but it definitely doesn't jump up as fast. So this material and Vantablack, which absorbs 99.9% of visible light, can be modeled as almost a perfect black body. And a black body is something that absorbs all types of radiation. And now for the interesting part. If I were to ask you whether you think that this material or the sun is a better black body, so does this material or the sun absorb light easier? Well, the answer is that the sun is actually a better black body than this material. The sun is almost a perfect black body, meaning because it has no solid surface, it's made of gas or plasma, it absorbs almost all radiation that strikes it. So it's weird to think that the sun is actually a better absorber of light than this dark black material here. The only reason the sun is bright though is because it's hot, so it also emits radiation really well. And it's actually very well correlated. The better something absorbs radiation, the better it is at emitting radiation. And leave me any comments or questions you have or any suggestions in the comments section and I'll try to get to them, and I'll see you next time.